class we are going to see preparation of dinitrogen, okay, because always nitrogen exists in the form of N2, okay, right. So commercially it is prepared by liquefaction method or distillating method, okay, because air contains both gases like oxygen and nitrogen, okay. First of all, liquid oxygen, its a boiling point is 90 degree 90 Kelvin. At the same time, for dinitrogen, its the boiling point is 77.2 Kelvin. Okay. So after the distillating funnel, applying the air, moisturized air. So what's happening? First, it's here the dinitrogen, its the boiling point is less compared to for liquid oxygen. So first it will distillate, okay, we can get the dinitrogen gas, okay. This is for easy way method because air consists of moisturized dinitrogen gas as well as the liquid oxygen gas. அது ரெண்டே என்ன செஞ்சலாம் distillating methodல easy என்ன செஞ்சலாம் separate பண்ணிடுறாங்க due to the boiling point is vary with each one, okay, right. So but in the laboratory preparations, so how the N2 gas is prepared? The first of all, take ammonium chloride in aqueous medium. The salt is treated with sodium nitrate. Okay. In the aqueous medium, we can get nitrogen gas and water and NaCl. Okay. Right. For this, the nitrogen gas is not pure form because of it contains nitrous oxide as well as nitric acid is present as the impurities for this nitrogen gas. Okay. So this nitrogen gas again passing through the ammonium dichromate at high temperature, we can get the pure form of dinitrogen gas and water and chromium trioxide. Okay. So this is for laboratory method. At the same time, it undergoes, so which one undergoes? Barium or sodium acid. Acid it undergoes decomposition reactions. You studied in your lower sections what do you mean decomposed reactions. So we can get the 2 or 3 types of product. Decomposed means split up, okay, divided into give the product, okay. Here the barium oxide in the heating to produce barium as well as a dinitrogen gas, okay. This is for your laboratory method, okay. What are the physical properties for dinitrogen? So it is a colorless, all the gases it is a colorless and odorless and tasteless and non-toxic gas, okay. So it exists in the form of isotopic in nature, N14th as well as N15th, okay. Very low solubility in water and low freezing and boiling points, okay. After that, so it is one point is left, it is inert at room temperature, inert at room temperature. Why? Because of it is N triple bond N, okay, 2 lone pairs are present here, 1 s orbital and 2 p orbitals, okay, sigma bond and pi bond, okay. So it undergoes p pi bond overlapping for these 2 nitrogen atoms, and also its a bond enthalpy is highest 441 kilojoule per mole, okay. It's a bond enthalpy also very high. So it is exist in the inert at room temperature, but we are going to heat apply. What's happening for higher temperature? So it react with both metals as well as non-metals. It produce concent nitrides, okay. Here the lithium, it react with nitrogen, dinitrogen. So it produce lithium nitride, okay. It is a covalent conditions, okay, sharing of electrons. But here ionic nitride and covalent nitride. Ionic nitride means that is interchange of electrons between the metals as well as the non-metals. Covalent means what? The sharing of electron between these 2 atoms, okay, right. So at the same time, this dinitrogen gas react with magnesium, produce magnesium nitrate, and also this dinitrogen gas is very useful for manufacturing of ammonia synthesis. For nitrogen gas react with hydrogen at the constant temperature, that is 773 Kelvin, and certain room atmospheric pressure, it produced ammonia gas. Okay, it is a this reactions takes place exothermic reactions because of the minus symbol it represent. It is a reversible and also it undergoes exothermic in nature. Okay, because of this reversible reactions favor the backward forward reactions favor the yield more ammonia. Okay, right. At the same time, this nitrogen react with dinitrogen react with oxygen gas, dioxygen gas at higher temperature. Note down that higher temperature it produce nitric oxide. Okay, and also so this dinitrogen gas is uses for where it is used for preparation of ammonia and other industrial chemicals like calcium cyanamide, and also it is used for it is room the main advantages, it is inert at a room temperature, so it is used in iron and steel industries. Okay, so and also this liquid dinitrogen used as a good refrigerant and to preserve the biological materials. Okay, biological materials na preserve பண்றதுக்கு வச்சிருப்பாங்கல்ல, ஃபார்மலின் வந்து earlier யூஸ் பண்ணாங்க, இப்போ liquid dinitrogen gasக்கு வந்து இது யூஸ் பண்றாங்க. Okay, and also preserve the food items as well as the cryosurgery. Cryosurgery, இது வந்து cryosurgery. க்ரையோசர்ஜரி அப்படிங்கிறது என்ன அப்படின்னோன்னா, இப்போ நம்மளோட ஸ்கின்னில் அன்வான்டாக வாட்ஸ் அப்படின்னு சொல்லுவாங்க, WART வாட்ஸ் அல்லது அந்த டியூமர்ஸ், அந்த குட்டி குட்டி அந்த இதெல்லாம் அன்வான்டாக இருக்கும்ல ஸ்கின்னுக்கு மேலே, அந்த மாதிரி இதை எடுக்கிறதுக்காண்டி யூஸ் பண்ணுறது தான் அந்த க்ரையோசர்ஜரி. ஏன் அப்படின்னா இந்த லிக்யூட் நைட்ரஜன் வந்து என்ன செய்யணும்னா அந்த இடத்துல கூலிங்காக இருக்கும். அப்போ அந்த டிஷ்யூஸ் வந்து என்ன செய்கிறாங்க, அவங்க வந்து அதை அந்த அன்வான்ட் டிஷ்யூஸ் ரிமூவல் ஆஃப் தட் that is called the cryosurgery. So the dinitrogen gas used as well as cryosurgery also. Okay, next compounds of nitrogen. Okay, ammonia is a type of compounds. Okay, compounds of nitrogen. Okay, now we are going to see the preparation of ammonia, how the ammonia is prepared by small scale as well as the larger scale. Okay, usually the ammonia is present in air as well as the soil, but it is formed by the decay of nitrogenous organic matter like urea. Okay, so this urea the hydrolyzation reactions takes place to produce ammonium carbonate. That ammonium carbonate decomposed to produce ammonia gas as well as the water and carbon dioxide. Okay, and also this is for larger scale preparation for ammonia. Okay, and also certain ammonium salt react with decomposed to give ammonia gas. Okay, this is for small scale preparations. NH4Cl, it is ammonium chloride, react with calcium hydroxide. CaOH twice means calcium hydroxide to produce ammonia water molecule as well as the calcium chloride. Okay, after that the another one method is ammonium salt like NH4 twice SO4 means ammonium sulfate. Okay, ammonium sulfate react with caustic soda. Caustic soda is nothing but alkali, NaOH, to produce ammonia gas and water, and Na2SO4 means sodium sulfate. Okay, so the salt, ammonium salt also react with the calcium hydroxide as well as caustic soda. Decomposition reactions takes place to produce ammonia gas. Okay, this is for small scale manufacturing. After that, another one method is Haber's process. Haber's process, the apparatus is look at here. This is apparatus for Haber's process. The amount of hydrogen for 1 parts of hydrogen and 3 parts of nitrogen gas, the gases are applying, and so during maintain the high pressure and temperature, suitable temperature, and also the presence of catalyst. Okay, hydrogen and nitrogen 3:1. Okay, or else 1:3 idla edutittu pressure, compress the pressure, because the according to our Le Chatelier principle, the highly pressure what's happen, the forward reactions takes place. Forward reactions takes place at high pressure. The volume completely reduced to produce the yield, that is ammonia. We can get the ammonia gas. Okay, right. So here the catalyst for using catalyst is iron oxide and the Al2O3 and K2O, it is a promoter catalyst. Promoter means this substance to initiate the catalyst for iron oxide, that iron oxide to speed up the rate of the reactions. This already we studied in surface chemistry lesson. ப்ரொமோட்டர் கேட்டலிஸ்ட் என்ன பண்ணோம் அப்படின்னா, நார்மல் கேட்டலிஸ்ட் வந்து ரியாக்ஷனை இனிஷியேட் பண்ணி விட்றதுனால கேட்டலிஸ்ட் வந்து என்ன செய்யுது, அண்டர் த சூட்டபிள் ப்ரெஷர் அண்ட் டெம்பரேச்சர் பிஃபோர் த இட் அட்டைன்ஸ் த ஈக்குலிபிரியம் we can get the expected product. Okay, so that is the presence of catalyst. Earlier the catalyst, it was used in molybdenum and iron. Okay, but nowadays it is used for the manufacturing of ammonia, K2O and Al2O3. It is a promoter catalyst. Okay, so at the suitable conditions, high pressure and 700 degree Kelvin temperature, what's happening, the nitrogen hydrogen react to produce ammonia, okay, right. So this ammonia easily soluble with water, we can get the liquefied ammonia. Then the processes rotations takes place again and again, we can get more amount of ammonia gas. Okay, this is what your Haber's process. Okay, the conditions, the important role should maintain the high pressure at a suitable temperature 700 degree Kelvin, and also the promoter catalyst as well as the catalyst. That's all. Okay, right. And now look at here, this is the physical properties. Colorless with pungent odor. Okay, so pungent odor means somewhat ஒரு மாதிரி the irritating smell மாதிரி. Okay, so freezing point, its a freezing point is 198.4 Kelvin, its boiling point is 239.7 Kelvin. Higher melting point and boiling point, highly soluble in water. Here one question we raised. So why ammonia is a higher melting as well as the boiling point and also high soluble in water? Because the ammonia structure is N, double, the lone pair of electron is present, it's bonded with 3 hydrogen. Okay, so 3 bond pair and 1 lone pair. Okay, so easily there is a presence of hydrogen bond, it associated with water. Okay, so easily the presence of hydrogen bond, it makes higher melting. We cannot break easily because of 3 bond pairs. Okay, and associated with water molecule, it is easily soluble. The presence of hydrogen bonds, it shows that it is a higher melting point as well as the boiling point. Due to the hydrogen bond, it is the reason it is a higher melting and boiling point, and also easily it associated with water molecule, easily soluble with water. Okay, that's all. Okay, and after that the ammonia gas soluble in water, so it acts as a weak base. Already we studied in amines chapter, ammonia is act as a weak base. Okay, so it forms ammonium salts with acids, it precipitates the hydroxides. Okay, with some many metals from their salt solutions. Okay, here the zinc sulfate react with zinc sulfate in the aqueous medium, react with ammonium hydroxide to produce zinc hydroxide as well as ammonium sulfate. Okay, after that ferric chloride react with ammonium salt like ammonium hydroxide to form ferric oxides in the hydrated form and ammonium chloride. Okay, right, because of it is a weak base, so it react with the acids like ammonium salt. Okay, and one question here, Lewis base. Why ammonia act as a Lewis base? The presence of lone pair of electrons. Lone pair of availability of lone pair of electron means to willing to donate the lone pair of electron. Here, so easily the presence of ammonia, the lone pair of electrons, so easily donate the pair of electrons to with metal. மெட்டலுக்கு ஈஸியாக வந்து பேர் ஆஃப் எலக்ட்ரானை டொனேட் பண்ணுறதுனால the linkage between the ammonium molecule as well as the metal to form the metal ammonium complex. Okay, so here one question we can raise. So the question is, why ammonia acts as a good complexing agent? The presence of lone pair of electrons ready to donate the lone pair of electron with the concerned metal to form the concerned what is that, complexes, to produce the complexes. Okay, for copper it produces the copper ammonium complex. It is a deep blue and silver react with chlorine to form silver chloride. This silver chloride is, earlier it is a colorless. After that, the produce silver chloride, it is a white PPT, white precipitate. That white precipitate react with ammonia. The lone pair of electron is present to form a complex, the silver ammonia complex, that is colorless. Okay, so where it is used to detect the cations like copper 2 plus and Ag plus. Okay, and Ag plus. Okay, so easily, because of, in case of Ag, so what is that, it is a colored to colorless, white PPT to colorless. In case of copper means blue to deep blue. Okay, so here how the ammonia we can get in the manufacturing of ammonia. This is for industrial process and smaller scale, as well as the and Haber's process, large scale process for to produce the ammonia. And physical properties, here the question, why it act as a Lewis base, and why ammonia has a high melting point and boiling point. These are the points, you keep it in your mind. Then last, ammonia uses. So it is used in some fertilizer, manufacturing of fertilizers for ammonium nitrate, urea, ammonium phosphate, ammonium sulfate. So these are the compounds of nitrogens. Okay, manufacturing of fertilizers, and some inorganic nitrogen compounds to produce inorganic nitrogen compounds, and the manufacturing of nitric acid, and also the liquefied ammonia used as a refrigerant, good refrigerant. Okay, that's all. Nitric acid. Okay, so nitrogen forms oxo acids like nitrous acid as well as nitric acid. Okay, so HNO2 means nitrous acid, HNO3 means nitric acid. Among these two, nitric acid is a more important commercially. Okay, so how the nitric acid is prepared? Okay, small scale, it is in the laboratory, it is prepared by normal nitrate salt like sodium nitrate or potassium nitrate in the presence of sulfuric acid to produce nitric acid. Okay, the large scale produced by Ostwald process. Ostwald process means the catalytic oxidation of ammonia to produce nitric oxide. That nitric oxide combined with oxygen to produce nitrogen dioxide. So that nitrogen dioxide soluble with water to produce nitric acid. Okay, so first of all, ammonia react with catalytic oxidation reactions. Which catalyst is used? Platinum. Okay, the temperature and bore pressure also, pressure and temperature maintained in the presence of catalyst produce nitric oxide. Nitric oxide combined with oxygen, and after the nitrogen dioxide soluble with water to produce nitric acid. Okay, so physical properties: colorless liquid, freezing point 231 point minus 231.4 Kelvin, boiling point is 355.6 Kelvin. Okay, in the aqueous medium it acts as a strong acid because of it produce the dissolved with water, it produce hydronium ion and nitrate ion. Okay, so it shows that it acts as a strong acid. Okay, so chemical properties: with metals, the nitric acid acts as a strong oxidizing agent. Because of the presence of the nature of acid, it produces different types of products. Listen, copper react with nitric acid. In the note down this here, dilute form to produce copper nitrate as well as the nitric oxide. Okay, at the same time, the same copper with concentrated nitric acid to produce copper nitrate and nitrogen dioxide. Okay, students, you keep it in that in your mind. At the diluted form, it produces nitric oxide. At the same time, concentrated nitric acid with metal to produce nitrogen dioxide. Okay, this is for varying. Okay, the product this is varying. Okay, right. At this for the another metal like zinc react with diluted nitric acid to produce zinc nitrate as well as nitrous oxide. Okay, this is nothing but laughing gas. Okay, at the same time, concentrated nitric acid, the zinc nitrate will produce nitrogen dioxide. Okay, so it acts as it depends upon the oxidizing agent as well as the nature of the acid to produce different types of compounds, nitrogen compounds. Okay, right. So the last one is brown ring test. So brown ring test here, it is a test for nitrate compounds. Okay, nitrate compound எப்படி அப்படிங்கிறதுக்கு நம்ம லேப்ல வந்து brown ring test பண்ணி பார்ப்போம். Here the Fe2 plus reduce the nitrate ion to form nitric oxide. Okay, NO. So this NO react with this Fe2 plus to form a brown ring complex. Okay, so suppose you have a nitrate salt. Take a pinch of salt with test tube and add freshly prepared ferrous sulfate solutions. Here the reductions takes place. After that, along the test tube you can add the little amount of concentrated sulfuric acid, brown ring produced. Okay, so the brown ring at the interfere between the solution and the sulfuric acid in the layers, it indicates the presence of nitrate ions. Okay, right. Here the uses of nitric acid is manufacturing of ammonium nitrate. So that is fertilizers, manufacturing of fertilizers and explosives and pyrotechnics and preparation of nitroglycerin and trinitrotoluene. So organic nitro compounds, the major use is it is pickling of stainless steel. Okay, and edging of metals. So it is and also it is used as an oxidizer in rocket fuels. That's all. Okay, students, this is very important reactions, react with metals because so completely following, most thoroughly for this chapter from many recent type of questions and draw the structures as well as completely following type. That completely following type questions from the preparations. So many preparations we studied now for dinitrogen preparations and before that ammonia preparations, and so like the from that only asked completely following type questions. And also this nitric acid react with non-metals also. For example, nitric acid react with iodine to produce iodic acid, and sulfur react to produce sulfurous acid or sulfuric acid. Okay, so this and all important, you keep it in that, and also concentrate recent type of questions.